Hi guys, welcome to our online unit on right-angled and non-right-angled trigonometry. So basically what we'll be going through is the booklet that you've all been given, and then what we'll do is spend the time in class on asking questions on how to do certain topics, and actually spending that time in having a go at some of the homework questions. So when we first look at this topic, we need to remember our idea on triangles and different triangle notations, but also certain things about angles. So what we're going to do is have a look at this first example down here, right? We'll notice that we're talking about right-angled trigonometry. There is something called Soh Cah Toa, and what we can use Soh Cah Toa is to find out the angle or side length of different parts of the triangle when given other parts of it. So if you remember Soh Cah Toa, O stands for opposite, A stands for adjacent, H stands for hypotenuse, and the S in Soh and the C in Ka and the T in Toa stand for sine, cos, and tan. Now, what we need to do is remember how we get to these different parts of the triangle. The opposite side is normally opposite our given angle, alright? So that's the Greek letter theta, and we can see the side that's furthest away from theta is our opposite side. Our hypotenuse is just generally the longest side on a right angle triangle, and we can also see that it is opposite the right angle. That's just the easiest way to find the hypotenuse. And our last remaining side in this example is our adjacent side. One last thing you'll also need to know is angles is normally measured in degrees, minutes, and seconds. So what we normally write, if we want to just talk about like 30 degrees, 26 minutes, and 45 seconds, alright? And this is easily found using the DMS or the circular button on your Casio calculators. And that's just how we can convert that. We also need to remember that 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. Okay? So make sure your calculator is in the degrees mode as we go through some of these questions. Now, the first question we see is this question up here. So we need to find the length of the unknown side x in the triangle shown. Some of you may be looking at this booklet and you're thinking, I remember some of this stuff in year 10. If you'd like to work ahead, that's perfectly fine. But what I'm going to do is work step by step through the booklet, and hopefully I'll be able to just timestamp when each slide is, so you can skip to the relevant slide and not waste as much time. So here we are solving x. Now what we know about this triangle is that x is the opposite side to our 35 degrees. So we're going to label an O and just stick that over there. What we also know is that this is the hypotenuse and this final side is our adjacent. So what we've actually got is we've got O and A and our angle as well. Now if I write Soh Cah and Toa, we'll notice that the only ratio that uses O and A is Toa. So what we'll do is we're going to write tan 35 equals x over 20, right? So what you'll need to remember is when you're writing Soh Cah and Toa, it's really like sine theta equals opposite over hypotenuse. It's really cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent, which is what we have here. Notice when we type tan 35 and 20 in our calculator, they're just numbers. So what we're going to do is we're going to actually rearrange this equation to try and find x by itself. So what we're going to do is times 20 to both sides. So we've got 20 tan 35 equals x. What we're then going to do is type that in our calculator. So 20 tan So we've got 20 times 10, 35, and we'll write our answer in. And it's set to 3 decimal places, so that's what we're going to leave it here. So when we're given a triangle with one side that's 20, one side that's unknown, and the angle that's 35, we know this last distance is actually 14.004. Okay, and so that's one example of Soh Cah Toa. Here is another one. So this example is us finding our missing angle. Now, what we'll need to do is we start off doing this the same method. We're going to label the opposite side. We're going to label the hypotenuse and our adjacent. And then we're going to write out Soh Cah Toa. And see which trig ratio we want to use. So we've noticed that it's this one here. So we're going to write sine theta equals 13 over 22. Now, with this example here, what we'll notice is when we're trying to solve for a fraction, what we'll need to use is actually the inverse sine button. How you find that is, notice how sine theta equals all this. We want to move over the sine theta to the other side. So what we're going to do is use this inverse sine. Now, by using this button, right, it's actually a combination of two buttons, we'll notice that the sine is here, but if we look carefully, above that there is a yellow button which has a -1 on top. And what we're going to do is we are going to press Shift Sign. We're going to put our fraction in, 13 over 22, and then push equals. 36.2215. Now, earlier before when we talked about degrees, minutes, and seconds, we knew that there was a button we can press to convert 36.22 into degrees, minutes, and seconds. So what we can do is press that button here. On an abacus calculator it says DMS, and then write our answers down like that. And so now we have it in degrees, minutes, and seconds. Okay? The next example we're going to go through is a written example. So here it talks about a vertical tent pole is supported by a rope tied to the top of the pole and to the peg on the level ground. The peg is 2.5 meters from the base of the pole, and the rope makes an angle of 63 degrees to the horizontal. What is the length of the rope between the peg and the top of the tent pole? Answer to 2 decimal places. Now, really what we have here is a right-angled triangle question, which again we need to use Soh Cah Toa. So the rope is actually this length here. And what we actually are given is, this time we're not given the opposite, but we are given the adjacent and the hypotenuse. So what we're going to do is we are going to use our car to find the length of the hypotenuse. Now, with this equation, we'll notice that if we substitute in some of the values, we get cos 63 equals 2.5 over h. Now, this is a little bit annoying to solve because our letter is at the bottom of the fraction instead of the top, but what we need to do is just multiply both sides by h, and that will turn into h cos 63 equals 2.5, and then we'll notice that we can divide both sides by cos 63, and then we end up with h equals 2.5 over cos 63, which we can type into our calculator. And make sure you close the brackets in there, and we get 5.51, which is our answer to 2 decimal places. Alright, some other people at this stage also know of a trick to make the bottom letter the subject, and all you need to do is swap what's on the top on the left hand side with what's on the bottom on the right hand side. As you can see, h is now the subject and cos 63 has moved to the bottom. Alright, and so this is how we answer our third question here. The last example we are doing today is an example with no diagram, but really what we can just do is, similarly with the top question, just draw in our right angled triangle and then use Soh Cah Toa to solve it. So this question asks about a rope being fixed with one end attached to the top of a 6 meter vertical pole. So what we're going to do is we're going to draw a line like this. We know that this is going to be 6 meters tall, and realistically we obviously just need a right angled triangle here. If we keep reading the question, we realize that the other end is pegged at an angle of 65 degrees with the level ground, and we need to find the length of the rope again. Now we'll notice that this is quite similar to our example above. Alright, so this time we are given the opposite. We're also given the hypotenuse, and this time when we use O and H, that means it's Soh, not Cah or Toa. And so we write sine theta equals O on H. We also know this time that the angle is 65. We know that the hypotenuse is what we want to find, and our opposite is 6 meters. And what we can do is we can use our shortcut method by swapping these two and getting 6 over sine 65. So we're almost done now. What we can do is just type that in our calculator, and then we find out that our rope length is actually 6.6 meters long. Alright, so that's all you need to do. You should be able to complete the questions at the back of your booklet. And I'll write that on the Google Classroom, and so that's all you need to do. So you should be able to answer the questions on the back of your Google. So that's the end of the video. You should be able to answer the questions that are on the back of this booklet. That's 4A, questions 3 to 6, every second letter, and also questions 9, 10, 13, 16, and 19. All of them using Soh Cah Toa.